Symmetry is really important to us. We like symmetry in the real world. We like symmetry in the things we see. And when things are asymmetrical, it kind of puts us off to the side a little bit and makes us just kind of skewed in some type of a way. Well, likewise, when we look at function or graphs, we want to determine some symmetry with those graphs. And one aspect of that is determining if the graph is even or if the graph is odd. So let me help you understand, how do we determine if a function is even or odd? So we say that when we evaluate a function, if f of negative x equals f of x, then we say that function, in that particular case, is even. If I evaluate the function at negative x and what comes out is negative of the function of x, then we say that function is odd. And I'll show you a couple examples to help kind of understand how that's different. Because right now, yeah, that doesn't make sense to me either. So let's look at an example that we have. So over on the right side, I have three different functions: f of x, g of x, and h of x. And notice that I have them labeled differently: f of x, g of x, and h of x, only to help me understand that there's three different functions. If I labeled them all f of x, you as a viewer would get confused. Which one am I talking about? So when we talk about functions, it doesn't matter that we use f or g or h or z. They're just there as a variable, as a marker, to let us know what particular function we might be talking about at any one time. So let's look at f of x, and you know which one it is because I labeled it f of x, not to be confused with the other two. I have x cubed minus 6x. So let's write that down, f of x, that's my starting function. And to find out if it's even or odd, I want to evaluate it at negative x. So let's see what that looks like. Negative x, that means I put a negative x in everywhere there's an x. Keep going down. That's negative x. I'm going to write this one out just so we can really see it. Negative x times negative x times negative x is negative x cubed. Minus 6 times the negative x, that gives me a plus a 6x. Negative x times negative x times it, that gives me a negative x cubed plus a 6x. And if you notice, the signs of each of these particular terms are the opposite of our original terms that we had right there. And in that particular case, and I can write it out where I have a negative out in front, negative of x cubed minus 6x, and I get the negative or the opposite of what I really started with. And so in this particular case, I have an odd function where I have f of x equals x cubed minus 6x, and I determined that this right here is basically f of x equals negative f of x. And then so I have an odd function. Let's compare that a little bit to the next one. And you're thinking, yeah, the next one's going to produce an even function. You're right. But let's look ahead and determine why does it produce an even function. So if we have an even function, my f, or in this case it's g of x, sorry folks. G of x equals x to the fourth minus 2x squared. So I want my g of x, when I put it into a negative, equal g of x. If that's the case, then I know I'm going to have an even function. So let's go ahead and evaluate that function at negative x. So I have negative x to the fourth minus 2 times negative x squared. Yep, that's correct. Let's evaluate that out. Negative x to the fourth produces x to the fourth. Negative x squared produces an x squared. Negative 2 times x squared gives me a negative 2x squared. And you'll see that I get the exact same function when I evaluate at negative x as I do when I evaluate it at positive x. And when that's the case, we know that we have a positive, or an even function. Lastly, let's evaluate h of x and determine if it's odd or even. So to determine if it's odd or even, we evaluate it at negative x rather than positive x. So h of negative x equals negative x squared plus 2 times negative x plus 1. And let's go ahead and clean that up a little bit. This makes it x squared minus a 2x plus a 1. And what you notice is two things here. You notice that I don't have, or I did not get the exact same function I began with at positive x, so therefore we know it's not an even function. And for it to be an odd function, each of the terms have to be opposite of what the original function was, and that's not the case either. The only one that's different is the 2x. And so because of that, I can say that h of x is neither even nor odd.